Hello everyone, myself Abhinam Pariyar from Namchi Government College, bearing roll number 18NS0009. First of all, I would like to thank my physics teacher, Dr. CP sir, for providing us this wonderful opportunity for the partial fulfillment of our physics honors BSc 6th Sem 2021. So moving on to my topic, gamma ray detector and proportional counter. So let us first understand the introduction part, what a gamma ray is. So a gamma ray is a penetrating form of electromagnetic radiation arising from the nucleus of radioactive substances. Now there are four major type of nuclear radiation that arises from the radioactive substances: alpha, beta, neutrons and gamma. Out of the four, the most common radiations are three radiations are the most common radiations: alpha, beta and gamma. And all electromagnetic radiation, as we know, all electromagnetic radiations can be described as a stream of massless particles called photons having a certain amount of energy. Since the gamma ray also arises from electromagnetic radiation from the nucleus of radioactive substance, it can also be described as a particle photon having a certain amount of energy. Now, a nuclear detector. Now, in this nuclear detector, it is a special kind of instrument, as we can see in the diagram, that works on the principle of ionization, and it can detect the existence of nuclear particle and determine the energy, momentum, direction, etc. Now there are three major type of nuclear detectors. Out of them, we are going to study about a gas filled nuclear detector, or it is also called as gas chamber. Now, working in principle, how does a gas filled nuclear detector work? It works on the principle of ionization. When a high energetic nuclear particle enters through a material medium, it ionizes the medium. As in this picture we can see, a radiation is entering into an atomic nuclei, and in an atom, the outermost shell, the electron in the outermost shell traps the energy from the radiation and gets excited, creating a free electron and a positive atom or ion. Now this kind of ionization is known as primary ionization, where the ionization takes place due to the energy of the incident radiation. Learning about a gas-filled nuclear detector. This is the general construction of gas-filled nuclear detector. It is made up of a hollow cylinder, and inside the hollow cylinder, it is filled with a gas medium, for instance, hydrogen air with at 1 atmospheric pressure. And inside the hollow medium passes an electrode through the center of the hollow medium, which is enclosed by an insulator and is further connected to the load resistance, which is further connected to the positive terminal of the battery. And the surface of the hollow medium or hollow metallic surface is connected to the negative terminal of the battery cathode. And the load resistance is connected to a device which detects and which measures the energy of the incident particle. So, as we know that the principle of the gas filled chamber is also ionization. So the greater the amount or energy of the incident particle, greater will be the ionization, resulting in the greater number of free electron and positive ion, and which results in a larger or greater current signal inside the detector. Now, as we see, we have placed a battery inside the circuit. Now, this battery is responsible for creating an electric field inside the gas chamber. And when the electric field is created inside the gas medium, the free electron and ions, they experience a certain acceleration which will attract the electron to the anode and which will attract the positive ions to the cathode, that is the surface of the hollow cylinder. And when the electron completes the circuit, a potential drop across RL is measured in the detector as a proof of existence of an incident particle with an energy or a radiation or a nuclear radiation. Now, moving on to the details, not only incident particle alpha, beta, gamma is responsible for the pulse count or bigger current signal, but it also depends in the potential difference between cathode and anode. So this graph shows what happens to the pulse signal when the voltage difference between anode and cathode is increased. So the gas chamber shows different characteristics when the voltage difference between cathode and anode is varied. As in the graph, in the first region, which is recombination region, when there is no or very less voltage, the free electrons and ion pair, they tend to recombine themselves because they do not experience any kind of acceleration. So due to some thermal motion, they will tend to recombine themselves, forming neutral atoms or molecules, and which result in um, zero potential drop across RL, which gives no signal, or with very less voltage it gives very less signal, and this region is known as recombination region. But as we increase the amount of potential difference to overcome or to stop the recombination process inside the gas chamber, we enter into the second region called ionization chamber, where the ionization of primary ionization starts happening. In the graph we see two lines. The red dotted line symbolizes or represents first incident energy E1, and the blue solid line represents the second incident energy E2, and with further increase in the applied voltage will lead to secondary ionization. The free electrons and positive ions, they receive enough energy from the high voltage supplied, and when they collide with the other gas molecules they impart energy and they ionize the other gas molecules, creating or forming secondary ionization. And in this proportional counter region, the pulse signal raises or increase proportional to the applied voltage. Now this continues in the beginning of the limited proportional region also, but by the end of the limited proportional region, they gets very much high voltage or the maximum voltage is feeded. So in the maximum voltage, the secondary ionization they leads to tertiary ionization, and tertiary ionization leads to a chain ionization process, creating an avalanche effect all over the gas medium or the hollow cylinder, and enters the Gregor-Muller counter region where we get a graph like a plateau, and with the further increase of voltage will not lead to the increase in the pulse signal. So this was all about how a ionization chamber or a gas filled ionization chamber works, and how from this graph we can determine or differentiate between energy of radiation that comes and enters the gas medium. The ionization chamber are good for detecting high energy particles, and whereas the proportional counter regions are used to detect less energetic particles. And in the Gregor-Muller counter region, a tiny particle of even less energy can create an avalanche effect in the entire chamber with respect to the maximum voltage. Thank you.